Hello, math scholars. It's a pumpkin perfect Monday, the week of Hoko. Who's excited? Okay, we're gonna start you off with the joke of the day. What did the stoplight say to the stop sign?
What?
Don't look, I'm changing.
Alrighty, here we go. Quadratic formula. Pretty excited. Alright, so we have a little bit of singing to do. Go ahead and write the formula down in your notebook first, and then we'll start. Sounds like you've already learned a song. This is exciting. Go ahead and write it down before we start singing.
Nate, I think you were at my class with Cleveland. I think you were.
In that case, you definitely
Play in the video.
Oh, yeah?
You might get copyrighted.
I don't care.
X equals the opposite of B plus or minus the square root of B squared minus 4AC, all divided by 2 times A. You join me. X equals the opposite of B plus or minus the square root of B squared minus 4AC, all divided by 2 times A. We'll do it again. X equals the opposite of B plus or minus the square root of B squared minus 4AC, all divided by 2 times A. Alright, that's probably good enough.
Copyright.
Alright, so this is a great way to remember. Now, when you are in pre-calculus next year with Mr. Poland, Mrs. McDonald, Mrs. Lippman, whoever you get, do not tell your teacher Mrs. Harp never taught this, because that actually happened this year. And Mr. Poland, it happened to be Mr. Poland, he called me up. He's like, I've got Joe Smith in here, and Joe says you never taught the quadratic formula. And I'm like, oh, false. Put me on speakerphone, and I'll sing the song for the class. I sang the song, hopefully sparking their memories. But jot this note down as well. Your math problem must be set equal to 0 before using the quadratic formula. If you're not set equal to 0, you're not going to be prepared to find that A, B, and C and solve it. Okay.
Who figured out this stuff?
Oh, a long time ago, like back in back before electricity. So they're sitting there by candlelight in like the 14 and 1500s, figuring this stuff out.
Why don't you just say the world is as it is?
I always wondered how, like back, let's just say it was like 1400, how they were figuring out stuff like this with no calculators, but yet they were not inventing electricity and cars. Like that's mind blowing to me that they could figure out this advanced mathematics.
Because they had so much time
without the
That's why
inventions.
they did this.
Right. All right.
They didn't.
Yeah, they just sat around and did math problems. They actually had like little learning communities where scholars went and lived, just figuring out math all day, every day.
Oh, yeah, I just realized it's still recording.
Yep. All right, we're moving on. It's okay. All right, we're going to go ahead and solve this one. First thing that caught my eye is it's not set equal to 0. So as you write it down, just be aware, having it equal to 2 is very bad. We're going to...
1.8.
Yeah, this is 1.8. We're going to need to subtract the 2 over to the left-hand side before we even consider quadratic formula. So this is the math problem that we're going to do the quadratic formula to.
Bless you.
All right, so just like before when we were doing things in vertex form, we have to identify A, B, and C. So can I have a volunteer tell me what A, B, and C are? 1, 3, negative 2. Yeah, make sure you make that C a negative 2. All right, we're going to sing this song really slow, and as we're singing, we're going to put numbers in, okay? Here goes. X equals the opposite of B plus or minus the square root of, let me get that square root huge, B squared minus 4AC, all divided by 2 times A. Alright, obviously you cannot head to the calculator and type all this in at one time.
Yes.
You just want to use the calculator for baby bits and pieces.
Yes.
What I want you to start with is just typing in the stuff that's under the radical. The stuff is called the discriminant, and it can tell you a lot about your answer. If the discriminant's negative, we're going to have imaginary answers. And if your discriminant's positive, we'll have 2 answers. If your discriminant is 0, we'll only have 1 answer. So it's good to know what that discriminant is right off the bat. So when you guys get what the discriminant is, let me know. Uh, 17 is what I got. I just did it mentally.
I just did it now.
It's just 9 plus 8. 9 plus 8. So 17. And honestly, 17, no one would break from jail. And so I can't really simplify any of this down. So I would just leave this as my answer.
That's a bad problem to start with.
I know. Well, you square rooted the 17. Alright, well, let's just go ahead and, since he did that, let's go ahead and find what the two decimal equivalents are. So if you want a real exact answer, this is how you'll leave it. If you want an approximate answer with decimals, you will continue your journey. What did you say it was 4.1?
4.12310.
So let's just go 4.1. Okay, thank you. Let's just go 4.1. So at this point, let me grab my calculator. You'll do -3 plus 4.1. Click enter. And then divide by 2. So one answer is 0.55. And then to get the other answer, you would do -3 minus 4.1. Click enter. Divide by 2. So that's -3.55. Now I'm going to show you, I have this little note at the bottom. You almost can't see behind all my stuff. This little note just says, if you want to check, your solutions will be the x-intercepts. So I'm going to show you on the calculator how you can actually use a function in the calculate menu to find those x-intercepts. Everybody grab your graphing calculators and get into Graph World. Graph World. Where you go? Alright, the thing that you want to put into Graph World is your equation when it is set equal to 0. So x squared plus 3x minus 2. Everybody graph x squared
JPB.
Plus 3x
plus 3x minus 2. And so those solutions are going to be our x-intercepts, 0.55 and -3.55. And I can see that's pretty darn close, but I can use something in the calculate menu to get it dead on. Nope, it's in the, so we've done things in table world. We're actually going to go into the calculate menu this time. It's something brand new we've never done.
Where do we go?
So it's going to be second trace. That'll take you to the calculate menu.
Okay, where do we go from here?
Now, which of these choices do you think would find an x-intercept for you?
Intersect?
Nope. 0, because x-intercepts are also called zeros. So it's choice number 2. You can go and select choice number 2, or just hit number 2.
I did.
Now, they're going to ask weird questions. They're going to say left bound question mark, and you just basically need to select a number that is to the left of the coordinate you're trying to find. So see how this coordinate looks like it's at about -3.5? Maybe select -5 as a left bound. You could just type the number in, -5.
I'm confused.
Or -55 in my case. And then you click enter.
Wait.
You're selecting any number that would be to the left of this point you're trying to find. So -55 would work, -10 would work. Any number that's to the left or smaller than the point you're trying to find.
Wait, what?
What?
We're turning smaller.
I'm really
Okay.
confused.
All right, I'm going to point with my finger. The people on the video aren't going to be able to see this. I'm going to point with my finger to the coordinate we're trying to find. Everybody agree right here? It's this x-intercept right here.
Yeah.
It's at about -3.5, right?
Yes.
Since they were asking the question, left bound question mark, we need a number that is further to the left on the number line than -3.5. So I'm going with -5. You could go with -6. You could go with -7. You could go with any number that's to the left on the number line than the point you're trying to find. So think of it as a number line.
I'm
Okay.
still
I'm going to pause the video at this point.
because I'm in this.
All right, so we went ahead and entered -5 and clicked enter. And Logan's like, it's still not giving the answer. I know. You have to stay patient here. They're asking for you for one more question. The question they're now asking is right bound. Let's think of our number line. If we're trying to get ourselves to the right of -3, to the right on the number line, what's a number that we should probably select?
-2.
-2 would work. Sure. Yep. So input -2.
Wait.
Wait, what?
Wait. Something 100%.
Oh.
Don't make me make you say the teenager out. I'm a teenager and I'm good at technology.
I'm not good at technology.
All right, now when it says guess, honestly, you can guess any number between these 2 points. What would be a good guess? Where do we think the x-intercept's at?
3.5.
Sure, let's guess negative 3.5.
Oh, it's this for each one of them.
It's not that bad though. Once you learn it, this process should take 5 seconds and not 5 minutes once you learn the process. And you got it, negative 3.56. So that's you verifying that our answer worked. Now honestly, Logan just said, do we have to do this for every single one? You only have to do this when you want to check your answer. So you're probably not going to do it every time. And once you understand this process, it should take you very little time. Okay? Let's try to do the same process to find the other x-intercept. Located up here at 0.55. Okay? So you start the process again. It is second calculation menu. These are all the calculation menus that you can do. So it's second trace to get in there. And then we're going with choice 2 because we're finding a 0, also called an x-intercept or solution. All right, so now let's think of our number line. If we want to find this point at negative 0.55, can you pick a point to the left of that? To the left of that? How about...
I put 0.
No, 0 would be to the right of it, so that would cause an error.
Oh, wait, we're the wrong one.
If you're here and you need a point to the left,
It's positive.
It's positive.
it's positive 0.55?
Yeah.
Oh, my bad, I forgot. I had my picture gone wrong on my board. Thank you.
I
So yeah, 0 will work. 0 will work. I'm sorry, draw my picture wrong. Okay, so 0 would be a great left bound. I like that idea, I'm sorry. And then I click enter. What would be a good right bound? What's a number to the right of 4.55?
I put 2.
2 would be fine.
2.
And then for guess, 0.5 maybe? Any number in between the left and right bound, honestly. And if you ever get an error, it's because your guess wasn't between your bounds, or your bounds were a little bit off. But it's 0.56, so that's going to verify our 2 answers that we've gotten. Now somebody's like, why don't we use table? Table only works if those solutions are at nice integer places, or maybe at like 1.5. These were at weird, crazy numbers. That's why the table probably wouldn't have showed these values. Okay.
I'm a teenager.
All right, here's our next one. Remember what I said about all of our problems having to be set equal to 0?
Ew.
Are we set equal to 0 right now? Not exactly. So, looks like we're going to have to subtract our 12x over. And looks like we'll have to add our 9 over as well. I'll do that all in one big step to save room. So that will give me a 0 on the right. I'll have 25x squared. Looks like a minus 30x because I'll be combining that negative 18 and a negative 12 plus 9. All right, I already have the be careful with your negatives. It's almost like beware. Beware of negative b values. So what's a and what's b and what's c?
25, negative 39.
25, negative 30, and 9. There's 2 places that negative b values will try to trick you. So I'll sing real slow and I'll explain that to you. Ready? X equals the opposite of b. That's the first place it's going to be tricky. What's the opposite of negative 30? Positive 30. Plus or minus the square root of, this is the second place it's going to be tricky. B squared is going to be a trick because when you square a negative, if you don't remember parentheses around that negative, it will calculate out wrong. B squared minus 4 times A times C, all divided by 2 times A. All right. So go ahead, type in the discriminant. That's that stuff in this pink circle. And report back to me on what you get.
0.
Oh, really? You got 0? Cool. I'll give everybody else a second to type it in. Yeah, discriminant is 0. Of 0 is awesome. Because when you square root 0, you just get 0. So it's almost like this whole second half of the equation is kind of gone on the top. I believe my only answer is 30 over 50, or 3 over 5.
I'm in cooking.
Okay, well, let me pause this up and try to help you out. All right, we did not end up checking that last one just because of the sake of time, but it would only have one x-intercept, and it would have been at 3/5 or 0.6. Okay, let's do this next one. Looks like it says solve an equation with imaginary. So we're probably going to have imaginary answers. That's exciting. That'll wake us up at 8:14 a.m. All right, we're still not set equal to 0. They're giving you lots of practice with getting yourself set equal to 0. Just subtract that 5 over to the left-hand side. It's negative x squared plus 4x minus 5 equals 0. What are my a, b, and c values? A, negative 1, B, 4, and C, negative 5. So I guess we're lucky we have a positive B value. That's nice. All right, let's start singing slowly. X equals the opposite of B plus 4 minus the square root of B squared minus 4 times A times C. Ooh, there's a lot of negatives there. Be careful there. All divided by 2 times A. There's a boatload of negatives, so be super careful when you go to type your discriminant in. You're typing in all this stuff in the pink circle, not including the square root yet. So it ends up being 16 minus 16 negative 4. Yeah, 16 minus 20. 16 minus 20. So negative 4. The bottom, I always multiply the bottoms in my head. 2 times negative 1 is negative 2. I said that wrong. 16 minus 20. Negative 4. 4 squared minus 4 times negative 1 times negative 5. Check your calculator screen that you typed in that. You don't need these parentheses or square positive. Alright, he's checking to make sure he matches me. Alright, let's talk about using imaginaries that we learned last week. The square root of negative 4 is going to be plus or minus 2i. And then that's all over negative 2. We are going to want to reduce that down a little bit. Let's make it look a little nicer. You can do the negative 4 divided by negative 2 and get a positive 2. And you can do a 2i divided by negative 2 and get a 1i. So I would probably write this answer 2 plus or minus 1i, like that. So basically both of the terms in the numerator get divided by that negative 2. All right, so we're going to talk about the discriminant and what it can tell you about the nature of the solution. The discriminant itself is just the b squared minus 4a part of it. B squared minus 4ac. I missed part of it, didn't I? B squared minus 4ac. It does not include the square root. It's just the stuff under the square root. But it can tell you whether you're getting real solutions, no solutions, or imaginary solutions. So this chart kind of describes what it tells you about the discriminant. If the discriminant is positive, there's 2 real solutions. I definitely want you to write down that part of the chart. I don't need you copying the whole chart, but you need to know that if the discriminant is positive, there's 2 real solutions. Visually, it'd look like this. I don't feel like you need to write that part down. If the discriminant is 0, there's 1 real solution. So visually, your parabola would be only touching that axis once. It would look like that. And then if the discriminant is negative, there's 2 imaginary solutions. So basically, the parabola would never, ever touch the graph. So just jot down the information in the pink box. That should be good from this chart. All right, so we are just going to real quickly find the discriminant of these guys and give the number a type of solution. So we don't have to solve the whole thing. We just need to find the discriminant and say simply there's 2 real solutions or there's 2 imaginary solutions. All right, so let's try number A. What is A? What is B? What is C? We are set equal to 0, which is nice. 1, negative 8, and 17. So we're just going to do a real quick b squared minus 4ac. We're not going to do the whole entire formula. That will be enough to tell us the nature of the solution. So b squared would be negative 8 squared minus 4 times 1 times 17. Let's see what that gives us. It gave me a negative 4. So if our discriminant is a negative number, what do we know about the solutions? Two imaginaries. And that comes from the fact we would need to square root that negative 4 if we were actually working out this problem. All right, let's try part B. Any questions on part A? All right, part B. A, B, and C. What's A? What's B? And what's C? All right, so B squared minus 4 times A times C. B squared minus 4 times A times C. What'd you get? I got 0. And what does that mean as far as how many solutions there are? One real solution. That parabola would touch one single spot. All right, and our last one. What can be done? A, B, and C. What's A? 1, B, negative 8. They give you a lot of practice with negative B values. And C, 15. B squared minus 4 times A times C. You already typed in and got 4?
Yeah.
Thank you. So it's a positive number. And if your discriminant is a positive number, what's that mean as far as how many solutions this would have? 2 real solutions. So the parabola would be touching 2 places on the x-axis. This is kind of a good recap of what we've basically learned up until now in this chapter. We have learned to solve equations with square roots, with factoring, and now with the quadratic equation. You would normally use the quadratic equation if the other 2 methods didn't work. So use it as a last resort because it's the most work of all the methods. Okay? And then go ahead before you leave here, snap a picture of what your homework is. It is a worksheet I'm about to pass out to you. Actually, you don't need to actually even snap a picture. I wrote that on the worksheet, so never mind the picture snapping. All right. Hey, thanks for watching the video at home. Sorry it was like 22 minutes. There was just a lot to do today. Bye-bye.